Hi, I'm Shijun Yan. I'm going to present how does the vertical horizontal illusion affect the lower limb. Let me start with the introduction of the vertical horizontal illusion. It's composed of two segments which are perpendicular to each other and with equal length. People often perceive a longer vertical segment. Many studies were designed to make comparisons between the visual illusory influences on perception and action. In some studies, visual illusion effects on perception are not equal to action. However, others claim that the illusory influences on perceptions approximate action. In our previous study, we found that stronger VH illusion influences were produced when people were forced to look at the center area of the configuration only, or their finger movement only. Thus, if such enhancement occurred in the upper limb movements, what about the lower limb? We aimed to determine whether the step displacements would follow the VH illusory influences similar to the upper limb. We hypothesized that the size estimations using the step would be more biased by this illusion when they fixed their eyes on the center area of the configuration, or the remembered configuration location during the step, comparing to look down during the step. We also hypothesized that the size estimates would be more biased after viewing this illusion than after viewing the single vertical segment. So here is the experimental setup. The stimulus was projected on this big screen, and the participants stood on a force plate. Participants first reported which segment looked longer. They stated vertical for the bisecting segment and horizontal for bisected segment, then produced a forward step to ensure that their step displacement was equal to the perceived vertical segment length. The step was performed on the floor, which was different from the stimulus presentation plane. There are three conditions. While making the step, they fixed their eyes on the segment intersection, which was the target fixation condition. Or while making the step, they still look at the intersection, but the stimulus disappeared. We call this remembered target fixation. The last condition is movement fixation. Participants looked down while stepping. These are the variables we analyzed. I want to explain the anticipatory postural adjustment variables. We used the force plate to measure the change of the central pressure, and the central pressure time and the central pressure amplitude were used to determine the motor planning. Our perception results suggest that the influence of the VH illusion on perception was evident. Just for information, the short stimulus means that the vertical line is shorter than the horizontal. Our main effects of size and gaze on the step displacement and peak velocity showed that the participants displaced the stepping foot more and faster for the long stimulus than the short stimulus, which were both longer than the control trials. The peak velocity was less when watching the movement compared to the other conditions. The vertical ground reaction force matched the results for peak velocity, suggesting that they produced the least vertical force for the short stimulus and when watching their movement. Step planning differed across gaze conditions. People took less time and often produced smaller postural adjustments when watching their movement in the MF condition compared to the other conditions. We also ran correlation analysis for the step displacement with peak velocity, ground reaction force, COP time, and amplitude. Few significant within-subject correlations indicate separate control mechanisms for the motor planning and completion. First, biased perceptual judgments and unbiased step displacement in our study contradicted our hypothesis that action and perception would be influenced by the illusion in a similar way. Thus, our results support the dissociation between action and perception. Moreover, the unbiased step displacement may be also caused by the stimuli and movement planes. Second, anticipatory postural adjustments did not associate with the step displacement and did not indicate greater imbalance, suggesting a change in the motor plan. Third, our force data partially support greater ground reaction force accompanied with bigger steps, and our peak velocity data suggested the potential for use of a greater visual feedback for the stepping, balance control, and in this case, a full sense of the movement accuracy. Lastly, we concluded that the potential distorted illusory effect during the required sensory motor transformations and plane transfer process may decay with available online feedback of the movement when people can look down while stepping. Thank you.